All right, Chapter 9, Section 4. This is Part 2 of Rational Expressions. Here in the notes, it says, always reduce the numerators and denominators before you multiply. Always, always, always take care of that first. You want to simplify first. All right, so if I look here, it says Problem 1, correctly simplified. Notice I've got 2x over y squared times y over 4 is equal to x divided by 2y. Now we want to know, is this correctly simplified? You know, I know a 2 is going to come out of the 4 and become a 2. And one of these y's is going to get kicked out, leaving me with 1 in the bottom. And that 2 already got divided out, right, into the 4. So I have an x there. So I can visually see that it is correct. But now let's do this part. Evaluate. Evaluate. So I'm going to evaluate on the left side of the equal sign and the right side of the equal sign and see if they're equal. All right, so if x is 3 and y is 5, then this becomes 2 times 3 over 5 squared times 5 over 4. All right, that's what I have on the left side of the equal sign. I'm going to simplify this. This is 2 times 3 is 6 times 5 is 30. Divided by 5 squared is 25 times 4 is 100. I can simplify this by crossing this off. And this is 3/10. All right, over here on the right, x is 3. This is 2 times y, and y is 5. Oh, look at that, 3/10. So it does work. We'll take a look at the next one, where it is incorrectly simplified, and we'll prove that it's incorrectly simplified by, again, evaluating both the left side and the right side. All right, so what does it look like, what happened here? It looks like the, whoever did this problem, it looks like they took a 2 out of here and out of the 4, except not realizing that this is a quantity, right? And 7 and 4 have no common factors. So this is done incorrectly, and we're going to prove it by showing evaluating. So this is 2x plus 7 in the top over y squared times y over 4. Now let's put the x in. X is 3. And these are both y's. Y is 5. I'm going to wait for this side till I'm done simplifying this side. Over here, this is 3 times 2, 6, plus 7 is 13 times 5. In the bottom here, I get 100. Well, 5 and 100 have something in common, a 5, right? I could rewrite the 100 as 5 times 20. I could divide out the 5s. Well, what do I have on the left side? 13/20. All right, the right side, x plus 7. X plus 7 over 2 times y. What's the x? X is 3. And y is 5. This here, of course, is 10 over 10. 10 over 10 is 1. 13 over 20 does not equal 1. Not at all. In fact, that's not equal. And in fact, that's not equal. All right, so be careful that you are actually only dividing out factors and nothing that comes from a sum or a difference or a quantity. All right, so what does it say here? The rule. Any numerator or denominator containing an addition sign, or a subtraction sign must be factored before simplifying. All right, it cannot, if it cannot be factored, put it in parentheses. Then it'll stop you from dividing out things that you cannot divide out. And if you have questions about it, please let me know so I can help you. All right, example 1. Simplify the fraction. Notice, I have dots. This is dots. You have to remember now all the rules of factoring to be able to do this. All right, dots. X squared subtract 64 is going to factor as x plus 8 times x minus 8. This is a trinomial. Easy. A is 1. Two numbers that multiply to 40 that subtract to 3. Well, that's 8 and 5. X, 5, x, 8, right? The difference between 5 and 8 is 3. Signs are different. Larger product is plus. 8x is bigger than 5x. Look now for common factors, numerator, denominator pairs. That's this times this. These are being multiplied. These are binomials being multiplied. So you could divide out common binomials. This is going to take that out. My final answer in simplified form is x subtract 8 divided by x subtract 5. This expression will exactly be equal to this one for every and any variable or value of the variable x, except for my restrictions. Folks, here x cannot be 5, and here x cannot be -8, because if it's 5 or -8, I'm going to get a 0 in the denominator. And we know we cannot divide by 0. Division by 0 is undefined. So how do you find your restrictions? Well, it's just like you're using ZPP when we were equation solving. All right? So part of the answer here is x cannot equal 5 or -8. Right? So this is my big answer, my final answer. This rational expression simplifies into this and is true for any value of x, except when x is 5 and -8. All right, well, I understand that -8 is not going to cause us a problem here. It will here. Okay, and we can't say they're exactly equal to each other if we don't put the restriction. So if you have questions about restrictions, please let me know. We've got 2 more examples. I will do this first one with you, and then for the next one, which is a division problem, but we already talked about changing the division to multiplication and inverting the divisor. I'm going to ask that you pause the video and do example 3 on your own. But we will do together example 2. Trinomial. This trinomial will factor. I like to write a really big, long division symbol. I'm going to factor this. A is 1, so it's easy. This big dot, I like to put the big dot because that big dot represents this dot. This here, that's not trial and error factoring. This one is. 2 numbers that multiply to 21 that subtract to 4, well, that would be 3 and 7. Signs are different. Larger product, again, is negative. Folks, this right here is GCF. You have to be able to recognize what sort of factoring is going on, or you're going to get these all not correct. Okay, GCF, a 5 can come out of there. 5 times the quantity, x minus 2. In the bottom here, well, 15 could be written as 3 times 5. X squared, well, I'm just going to write it as x squared because I don't see any x's by itself up top. big dot, that's that dot, right, separating. Multiply 6, subtracts to 1. Well, that would be 3 and 2. So that's x2, x3. Signs are different. Larger product is positive. And now I'm ready to divide out common factors. Notice that anything that has a plus or a minus in between has a parenthesis around it. They are quantities. You could divide out common quantity factors. All right, so let's check across the top first. Is there an x plus 3 in the bottom? Yes, there is. So I can cross them out. They're going to equal 1 when they divide out. Is there an x minus 7 in the bottom? There is not. Is there a 5? There is, and that's why I rewrote 15 as 3 times 5. Is there a quantity x minus 2 in the bottom? There is. So they get crossed out. What remains in the numerator? There's only one item, an x minus 7. What remains in the denominator? 3x squared. Folks, you cannot divide this x squared with this x. This is a quantity, and it has to be presented as such. This is my answer in simplified form. I only have x as a variable, so I'm going to say x is not allowed to equal 0 here, right? If I put a 0 in there and square it, multiply it with everything, x can't be 0 there. X can't be positive 2 here. X can't be negative 3 here. So there's my simplified answer along with my denominator restrictions. If you have questions on that, please let me know. All right, so I did go ahead and ask that you would try the next one on your own. Now remember, you are going to have a little bit more places to look for denominator restrictions, so keep that in mind. All right, so I'm going to pull this up here. I recommend that you change this and flip this first. I also recommend after you factor everything, you look for restrictions right away. Okay, so pause the video and see what you can do with this problem. All right, hopefully you paused the video and at least got to here. So I changed the division to multiplication, and don't forget you have to flip that fraction. You have to invert the divisor. That's step 1. Then you need to look at these and figure out what kind of factoring is happening. Folks, when I have two terms, one's quadratic, one's linear, that's GCF. This is GCF factoring. This is prime. Quantity x plus 3 cannot be factored anymore. There are no common factors that exist. This thing is a trinomial. This is going to factor trial and error. Two numbers that multiply to 18 that add to 11. Well, that's 9 and 2. Signs are the same. They're both plus. All right, and I could do that quickly because a is 1. Two terms. Always look to see, do both of these terms have x's? See if it's GCF first. You're always supposed to be checking for GCF first anyway. That's GCF. 15 divides 45 and itself. And I could take 2 x's out of each. So my GCF is 15x squared. All right, now I'm ready to take some numerator-denominator pairs. All right, 5. Is there 5? There's not a 5, but there's a 15. Folks, can I rewrite this as 5 times 3? Right? So when I rewrite it as 5 times 3, this 5 can take that 5 out. The 3's still there. This x will take out one of these, leaving me with 1x. Quantity x plus 2, it goes. Quantity x plus 3, it goes. Now, after I'm done crossing off numerator-denominator pairs, I got to write what remains, what's left. Folks, just because everything went out of the numerator doesn't mean there's nothing there. This is all times 1. You can't forget to put the 1 there. What's left in the denominator? Well, I've got this is gone, this stays. That became that, and that went. These stay. Everything else is gone. So I've got 3x times quantity x plus 9. So that's my simplified answer. If I'm looking for denominator restrictions, x is not allowed to equal, well, let's look up here in the factored version. X can't be negative 2, can't be negative 9, it can't be 0, it can't be negative 3. And now remember, this plus 3 was an original denominator. And there it can't be negative 3. I already have it in there. So this is my simplified version of the answer along with the denominator restrictions. So let me know if you have any questions so that I may help you with this. You can ask in a Google Meet or in the classroom when you're in class. Have a great day.